Hello. Some of these mistakes I've seen done by different people on posts and forums several times. Others I've made myself when I was very new to electrics. And some of them I think are maybe just mistakes that beginners may make. No particular order. Number 1. Not using fuses at all or putting them in the wrong place. This was actually one of my first systems quite a few years ago. No fuses. Diagram wise it would look like this. It's not the way to do things. Nothing is protected. This is a little bit better, but still very bad, and I've seen this countless times. It seems to be almost the most popular thing for beginners to do, and it only protects part of the wire. If you put them here instead, by the battery terminals or bus bar terminals, you end up protecting the whole length of the wire. Number 2. Insulation pinching or using the washer or nut as a conductor. The conducting parts ought to be flush against each other for maximum connection and to avoid hot spots. So don't put any washers, lock washers or nuts in between the actual conducting parts, in this case the lug and the fuse, because you don't want current to have to flow through the washer or the bolt or the nut, because they are often made of steel and also they decrease the surface area a lot. Instead, have some of the washers be at the bottom as a good base. Then have the lug connected directly onto the fuse. You won't get a better connection than conductor flush against conductor. Finally, add the normal washers as well as the split washers or spring-loaded washers. And lastly, the nuts, just to hold them down. The same can be said for wires with the lugs attached to bus bars. You want it flush. That's a good connection. But even without washers or nuts in the way, you might still end up pinching some insulation or heat shrink. Now, I haven't got any heat shrink that size. I've run out, I'm afraid, but just imagine that it's on the actual wire. And some people accidentally put it on so it's like that, thinking it will cover more, or they do it by accident. But you don't want it to cover that much because, as you can see, I've pinched the insulation. And now there's a gap there. Obviously, I've folded it and I've exaggerated it here, but you get the idea. It's a terrible connection and you will get hot spots. It will heat up a lot. Same goes for here. Okay, final example of pinching insulation. With these sort of terminals, you can accidentally pinch the insulation because with these miniature circuit breakers or any sort of device with terminals like this, when they're mounted on the wall or in a consumer unit, they have this terminal facing down and another one on top. So many times, unless you're crouching or you bend your head over, you're not really going to be able to see what you're doing and you might pinch it. You might do that, or you might do this, which is the opposite, having too much of the copper visible. When I used to study electrics, I saw people in my class do this constantly. Not everybody, of course, but it was not uncommon. This can increase the risk for short circuit or electrocution, so do it properly, which is to say, have the copper in, but not so much in that it pinches the insulation. Something like this. Number 3. Using solid core or 7-stranded wire. These are mainly used in buildings, stuff that don't move and vibrate. So not machinery and not vehicles. They are stiff and easy to shape, so it might look good on the outside of a wall if you have a cable running. You can make sharp 90-degree angles. The 7-stranded is a little bit more flexible and can go inside conduits a bit easier. I get it. It's tempting to buy the cheaper 7-stranded or solid core, but get multi-stranded even if it is a bit more expensive because it will last way longer. Let me demonstrate. So we've got solid core, 7-stranded wire, and multi-stranded. Obviously, I can't wait months in a vehicle for this, so let me just demonstrate real quick by being extra violent. Just a few seconds. Next up, the 7-stranded wire. It survived a bit better, about twice as long, but that was only about half a minute still. Then, most of them came off. A bit longer, and boof, they all come off. Now for our final contestant, the multi-stranded wire. I went for, I don't know, 3-4 times as long with this one, and I was also a bit more violent because I really wanted to break it towards the end. But honestly, it kept up surprisingly well. I mean, this must surely be a very shaky van. There, finally. A few strands came off, but we've still got the bulk of it there. And we've been twice as violent with this one and gone for like 3-4 times as long. And a few more. But pass the test, use this wire, and save this for perhaps houses. Number 4, solder versus crimp, specifically with lugs and maybe wires. Crimp them and use a tool like one of these. There are quite a few different ones that aren't too expensive and are very good. You'll get a much better connection. Crimping is easier, it's quicker, and also just better. So what some people will do is they'll take a lug, they'll take some solder, they'll break pieces off, and they'll feed it into the lug, and when they think it's full enough, they'll just take some torch or a flamethrower, heat it up until it all melts, and shove the wire right down. Crimping with the right tool is far more superior because the solder, which is mostly tin, does not conduct as well as copper. So all you're doing is putting a barrier of something that doesn't conduct as well between the actual copper and the lug. Also, it's not as strong because it can crack with vibrations or temperature changes. And unless the wire hasn't already come out by then it will very soon, because once it's cracked, you might get hot spots. With heat, the solder will melt and then the wire will come out. I'm not saying never solder, because it can be good for smaller things that don't weigh a lot, and like LED lights, resistors on circuit boards, because first of all, you can't really crimp them, but also they don't have a lot of weight and there won't be as much stress on them as, for example, a big lug. Speaking of big lugs, this is what I use to crimp my big lugs. I think it costs about €30. So all you do is you adjust the setting for the right size lug, and then you put it in there with a wire inside, of course, and then you just simply crimp it. Not going to do it in this video though. I'm not going to lie, I'm kind of not very rich, so I'm not going to waste an expensive lug. But I've got one prepared here from a few years ago, and this one is for some reason covered in tape. I think I changed the colour of it, but never mind. Let's remove that, and that's what it looks like underneath once you've crimped it. I don't know why I crimped it twice, but yeah, that's never coming off. Anyway, number 5, using the wrong tool for crimping connectors. So you've got your wire, and you've also got your fork connector, or any other connector for that matter, but you decide to use a pair of pliers, and specifically the sharp edge of the pliers, because you think that you'll get a better pinch that way and simulate the actual crimp tool. Oh dear, not very good. And we're left with this. Not very useful. Perhaps we can try to insert it in there. Kidding, don't do that, that's just bad. Anyway, this thing also comes off really easy, so just don't use pliers. Look, we even damaged some of these copper strands. Very bad, don't do. But aha, what about this? This is flat, this will not cut anything off. You simply squeeze it with all your might. You can even step on your hand with your foot if your other hand is preoccupied with filming. Though I did end up using both hands in the end, but will it stand the pull test? No, it did not, and it actually came off a bit easier than I expected. And this isn't rigged. I did try to crimp it well, but it just didn't crimp in the right way and with enough force. This is what you'll want to use, or something similar. Now this is the budget version still, but it does the job. So you've got colour codes there for the different sizes, and you see that little lip or tooth or whatever that is. That's the part that will actually press down onto the wire. Make some clicky noises, and once it does the final click, it will allow you to release it, and you know that it will have crimped hard enough. Let's try to pull it off. Pull test passed. Now I don't want to be a pooper of parties, but if you got these ferrules or perhaps some other connector, you can't always use this particular one, even if it's for crimping. This one is only meant for crimping the classical ring, fork, spade connectors. But let's try it anyway. Yeah, not the best. Bad, don't do. For ferrules, these pliers might actually be better, but yeah, I don't think they'll be great. It looks sort of almost decent, but it will fail anyway. So let's get a new ferrule and do it with a proper crimp tool. And keep in mind, I am not rich, so these are still budget tools. But they do the job, and they do it well. Way better than pliers could have done. Let's try to pull it off. Pass. Anyway, number 6, buying cheap non-copper lugs or connectors. If we compare these lugs, you can definitely tell a difference. I bought the cheapest ones I could find on Amazon, and I was disappointed. I mean, I knew I wouldn't get anything great, but I didn't expect it to be that bad. They didn't weigh of anything. I think they were aluminium or something else, even though it said copper. And also, just the thickness of it tells me that it can't carry nearly as much as my quality lug can. Or my quality lug, I bought them from a shop, but yeah. Same goes for these. Chances are that if you buy the cheapest stuff, you're going to get the nastiest stuff. It might not be copper, it might be brass or aluminium or just a few percent copper or something else. Check the data sheets. Of course, they don't always tell the truth, but good brands will generally not lie, or they're less likely to anyway, because they have a reputation compared to the, well, unknown brands. Mistake number 7. Using the wrong tool for stripping the insulation. For stripping wires, I've seen many tools be used. Some are good, some are bad. I wouldn't recommend using knives. They aren't generally good, especially for multi-stranded, as I can easily cut them off. They could work for solid core a bit easier, but I still wouldn't recommend it. I've seen people strip wire like this, specifically solid core, and then just pop it off. But for multi-stranded, and especially if the insulation is a bit different, like a bit more rubbery or just stays intact more easily, it could prove difficult. And also you run the risk of cutting yourself, like I did here. That was a bit clumsy. If you're careful, it works in a pinch, but there are way quicker ways of doing it because this is kind of slow, to be honest. Okay, I think I stripped it off alright, and I don't see a lot of damaged strands, but there. See how easy it is to cut them off if you just go a bit too hard, and your finger. So away with you, and try this instead. This is an automatic wire stripper. Of course, the quality varies depending what brand you get. This one is alright. I have tried better ones at work before. They are perfect, but they are so expensive. This one is not expensive. It's very quick. I have noticed that sometimes on these fine stranded ones, it can accidentally like chop one or two off. Yep, like there. But I can also try adjusting it a little bit. It might have been too strong. And there we go. Tried it again and it worked. You can buy a really good quality Knipex one, but they are more expensive. So even with this cheap version, it does a way better job than the knife. Next up is this one. I like this one quite a lot. It's a bit more awkward to adjust compared to the automatic one, but once you've adjusted it to the size you want, you can use it over and over again without stripping any wire, because that hole there, if you ensure it's bigger than the actual conducting part, and it slides in and out, it's kind of impossible for you to strip the wire, unless you press extremely hard. But because it takes a bit of time to adjust the size compared to like the strength on a automatic one, I'd say use an automatic one if you've got loads of different wires that you're going to alternate between, and this one if you're just going to stick to the same size. For wider wires or cables, you can use one of these. You simply open it up, and then of course this wire is severely undersized for this tool, but you get the idea. You spin it around and then you just pull it off. You can also use these, but I don't recommend it. I have actually done it many times, so I'm a bit of a hypocrite for saying this, but it's so easy to accidentally nick a bit of the copper strand. But basically what you do, if you are to do this, you very carefully cut the insulation and then just bend it back and forwards, but it's not the best one to use. Now, if you have cable and you want to get the outer sheath off, I have something called the banana peel method. It works with some insulation, not every single material. Anyway, you chop those off first, and secondly, you get a pair of pliers or the same pliers and chop down the center like that. And you pull at both ends like a banana. It works for some cables, some insulations don't allow you to do it. If that's the case, you might have to cut down the actual insulation first, but do it with a knife carefully, or use one of these knives with a solder tip on the end so that you can't actually damage the wires underneath the first sheath. Anyway, number 8, and the final mistake, using aluminium wire instead of copper wire. Copper can handle more current than aluminium if both wires are the same size, as copper conducts better. Copper is also more durable. It's not as brittle as aluminium and won't snap as easily during vibrations. It can bend many more times. Also, even though aluminium might seem cheaper than copper, you'll need to buy a lot thicker aluminium wires to be able to carry the same amount of current that copper can carry. So it ends up costing a bit there anyway, but even if it would be cheaper to do it that way, because of the brittleness, I would still go for the copper wire. It's also more available. Aluminium wire still has its place in this world. With high frequency AC, alternating current that is, there's something called the skin effect. What happens is most of the current flows, or maybe not flows, but oscillates on the outside, like not in the center. So then you can fill the center with aluminium because it's cheaper, and then the outside of copper because most of the current will be like on the edges anyway, depending of course on what system it is and the voltage and frequency and yeah, a bunch of other factors probably. I'm not an expert when it comes to that, but I know that DC, that is direct current, like batteries and solar panels, does not have this problem or this skin effect, and therefore don't use aluminium, just use copper wire. Multi-stranded copper wire, that's all you need for a van.